All right, so we're going to start today with an introduction on moles and Avogadro's number. We have all seen this. This is the periodic table of elements. Let's use helium as an example. Helium is located on the top right-hand corner. It has an atomic number of 2, and what we probably know by now, the atomic mass, and that's at the bottom. The atomic mass also is known as the atomic mass units. That's the unit of measurement for these values at the bottom of each of these elements. But what does that actually mean? What does AMU mean? So AMU has been invented by someone known as Avogadro, and this is his number. He was mathematically able to calculate that as long as you multiply 6.02 times 10 to the 23 to whatever you're trying to find, you can somehow quantify what the atomic mass actually means. He then created a link between mole, something that is also very abstract. There's no way you can measure mole, but although you can't physically measure it, as long as you can calculate the link between mole and Avogadro's number, you will be able to quantify something. So in this case, 1 mole is equivalent to 6.02 times 10 to the 23. 10 to the 23 could be of things, right? Things like atoms, could be things like molecules, things like particles. Now we want to try to understand a little bit more about how Avogadro's number is related to moles. The word mole and the term comes from a standardized unit of measurement derived from carbon-12. So in order to find the number of atoms, in this case, they used carbon as the standard. So 12 grams of carbon-12, so carbon that has the atomic mass of 12, because not all carbons have atomic masses of 12, right? So 12 grams of carbon-12 is equivalent to exactly 6.02 times 10 to the 23 of carbon atoms. So simply said, you could say that this is equivalent to 1 mole. So they're able to come up with the unit of measurement of mole from the standardization of 12 grams of carbon-12. So what does this mean exactly? You have moles on the left side and you have Avogadros on the right. So this tells you that 1 mole of copper metal and 1 mole of water and 1 mole of salt, okay, is equivalent to 6.02 times 10 to the 23 copper atoms, okay, is equal to 6.02 times 10 to the 23 water, H2O molecules, right? You use atoms to describe one element, but when elements are chemically bonded together, you use the term molecules. You also have 1 mole of salt, equivalent to 6.02 times 10 to the 23 of sodium chloride molecules. So this is saying that 1 mole of copper metal, 1 mole of water, and 1 mole of salt, they all equal to 6.02 times 10 to the 23. So now we know this magic number, Avogadro's number. Avogadro's number is always expressed as A with a subscript of N. Let's take a look at how mole and Avogadro is related. When we want to find 1 mole of something and we want to convert it into the number of things, so it could be atoms, it could be molecules, particles, anything we've seen so far, you multiply Avogadro's number. When we do not want to go this way, but we want to go the reverse, so we want to convert from atoms into this abstract mole, then we divide by Avogadro's number. So again, from moles to atoms, molecules, particles, you multiply. From atoms, molecules, particles to moles, you divide. Now let's take a look at an example. Consider 4.5 moles of water molecules. So you have a water molecule. Water molecule is H2O, right? This means the oxygen is in the center. It's the central atom. And you have two hydrogens chemically bonded to the oxygen. So how many molecules is this? This means that we are converting from moles to molecules, so we need to multiply. So we multiply by Avogadro's number. 4.5 moles multiplied by Avogadro's number gives us 27 times 10 to the 23 molecules of water. And now, how many atoms of hydrogen are there? So to convert to hydrogen, we see that one molecule of water equals to 2 atoms of hydrogen, right? So in one molecule of water, we have 2 atoms of hydrogen. If we have 2 atoms of hydrogen, then it means in 4.5 moles of water, then we have 2, right? We have 2 hydrogens, so we multiply 2 by the number of molecules that we have calculated earlier. And that gives us 5.4 times 10 to the 24 atoms of hydrogen.